Okay, so today we're going to be graphing proportional relationships. So we're going to start with the Explore It problem. The graph shows the time it takes JC to print t-shirts for her school's math club. Okay, so we have a graph here. Number of t-shirts is on the x-axis and then time is on the y-axis. So if you just look at the graph, it says one t-shirt took 5 minutes, 2 t-shirts took 10 minutes, 3 t-shirts took 15 minutes, and so on and so forth. Use the points on the graph to complete the table. Are the quantities proportional? Okay, so I'm just going to write what I just said. 1 t-shirt, 5 minutes. 2 t-shirts, 10 minutes. 3 t-shirts, 15 minutes, and 4 t-shirts, 20 minutes. Are the quantities proportional? So we can do, remember, it's always y over x when we're finding the constant of proportionality. So 5 over 1 equals 5, 10 over 2 equals 5, 15 over 3 equals 5, and 20 over 4 equals 5. So yes, because the ratios are equivalent. B, start at 1, 5. As you move from one point to the next on the graph, how does the x-coordinate change? How does the y-coordinate change? So if we start at 1, 5 and we want to move to this point, we have to go over 1. So this is our change in the x because we're going to the right. We have to go right 1 and we have to go up 5. It's not up 1 because our scale is 5 here. So our x-coordinate increases by 1, and the y-coordinate increases by 5. Over 1, up 5. Write points for 0 t-shirts and 5 t-shirts as ordered pairs. Graph the points and draw the line that passes through all 6 points. Okay, so if she's making 0 t-shirts, that's obviously going to take 0 minutes. And then we just kind of continue here. So if she makes 5 t-shirts, that's going to take 25 minutes. So the coordinate points are 0, 0, and 5, 25, right? 0, 0, this is 5, 25, it's always x, y, we've learned that. Okay, next. Graph to recognize a proportional relationship. Okay, so Tanya exercised for 30 minutes. She noted the calories burned at 3 times during her workout. How can Tanya use this information to find how many calories she burned after 15 minutes of exercise? So if you look at this, it says she burned 95 calories in 10 minutes. She burned 190 calories in 20 minutes and 285 calories in 30 minutes. And then it's shown here on the graph as well. So obviously also 0 minutes would be 0 calories burned. 10 minutes is 95. Now it almost looks like it's at 100. It technically is a little bit below 100, so it's 95. So just ignore that it looks almost like it's on the line. Okay, so it is proportional, this relationship, because it's a straight line and it's passing through the origin. So this is the origin. The origin is 0, 0. Use the graph to find the constant of proportionality. Well, if she's burning 95 calories in 10 minutes, that's 95 over 10, okay, y over x, which is 9.5. So it's 9.5 calories, cal per minute, that she's burning. So this is showing you on the graph, you're going up 95, you're going right 10, this is your y, so 95 divided by 10, okay? So then it asks how many calories she burned after 15 minutes. So your equation here is y equals 9.5x, right? Because y equals kx and k is 9.5. So 15 minutes, you're plugging in 15 here. So 9.5 times 15, if you put that in the calculator, it's 142.5 calories. The triad says each 1/4 serving of cereal has 3 grams of protein. How can you use the graph at the right to determine whether the quantities are proportional and to find how many grams of protein are in 1 cup of cereal? So before I even start graphing, I'm actually going to find the constant of proportionality. So cups is your x value, okay? So this is x, right? Because this is cups. Your y values are the grams of protein, so this is the y value. And remember, we do y over x, so it would be 3 over 1/4, which is the same thing as 3 divided by 1/4. Keep, change, flip. You can put that over 1 if it helps you. 3 times 4 is 12. So 12 grams per cup. We're going to graph this as well. So 1/4 cup is 3 grams. If we add another 1/4 to that, that would make it a half. So you also have to go up 3 from there. So 6. 3/4 goes up to 9. And then this last one's going to go off the graph. 1 cup, so per cup, is 12 grams. So that would be 10, 11, 12 would be like up here. And we can connect that, and it makes a proportional relationship because it's linear, it's going through the origin. How can you find the constant of proportionality from the coordinates of 1 point on the graph? Well, we did that. We divided, so you divide the y-coordinate by the x-coordinate. And it doesn't matter which point you pick on your graph. Like we did 3 divided by 1/4, but you could also do 6 divided by 1/2. You're going to get the same thing, or 9 divided by 3/4. Okay, example 2. Interpret the graph of a proportional relationship. The graph shows a proportional relationship between the distance and the amount of time Mr. Brown drives. Okay, so it's saying that what does each of these points represent in the situation? So at 0 hours, he hasn't driven any miles, right? At 1 hour, after 1 hour, he's driven 55 miles. If it asked us for 2 hours, he's driven 110. So 155, and then it asked for 5, 275. So after 5 hours, he's driven 275 miles. The constant of proportionality is y over x. 55 over 1. So the equation is y equals 55x. Suppose the graph of Mr. Brown's road trip is extended. Find the ordered pair with an x-coordinate of 7. So we can actually just use our equation for this. That's really the easiest thing to do instead of extending the graph. So the equation is y equals 55x. Y equals 55 times 7. We're plugging in 7 because x is time and it's asking for 7. So 55 times 7 is 385. So 385 is a point. It means that he drives 385 miles in 7 hours. Example 3, recognize graphs of proportional relationships. Explain why each graph does or does not show a proportional relationship. So this first one, yes, it does, because the graph is a straight line. And passes through the origin. So it has to have those two things. It has to be a straight line, and it also has to pass through the point 0, 0. If it doesn't have those two things, then it's not proportional. So this one is going to be no, because even though it's a straight line, it's not passing through the origin. It's never passing through this point. So no, it does not pass through the origin. Okay, this next one is no. It does go through the origin. If you look at it, it continues all the way to here, but it's not a straight line. It's all bent here. So it is not a straight line. Okay, for this question, it says draw two graphs that pass through the point 2, 3, one that represents a proportional relationship and one that does not. Label your graphs as proportional or not proportional. So there's so many different answers you could have for this because you definitely need to plot the point 2, 3 on both graphs. So 2 is your x, and then you go up 3. Same thing over here, 2 is your x, go up 3. I want to say that this one is going to be proportional, and this one is not proportional. That's how I'm going to do it. Okay, so if I want to make a proportional relationship, it has to go through the origin. So it has to pass through 0, 0, and it has to be a straight line. So there we go. This one, I'm going to make it not proportional, so I'm going to make it, you can either make it not a straight line, like you could do something like kind of like curved, or you could just make it not pass through the origin, so I'm going to start it here instead, like that. There's some additional notes I want you to take, so you can just write more on proportional relationships. Just to kind of recap. Okay, so something that the book did not go over that I want you to know is that the exponent of the variable of the equation must be 1. So you're probably thinking, what does that mean? Well, I'm going to show you a couple examples. So example, y equals 2x. So here's our variable, right? Well, we technically have two variables, but I'm talking about the x variable. The exponent on this is 1. Isn't there really an imaginary 1 there? So since the exponent is 1, it is proportional. Now for this one, y equals x squared, the exponent is 2. So since the exponent is 2, it's not proportional. If you graph this, you're not going to learn about how to graph this until Algebra 2, but if you graph this, it's going to make a U shape. It's called a parabola. It's going to look like that, which is not a straight line. Okay, next thing I want to review is that the equation needs to be in the form y equals kx. So example, y equals 6x. Yes, that is in the form y equals kx. Another example, y equals 6x plus 1. This one would be no, because this part is y equals kx, but then we have this plus 1 over here. It cannot say plus 1, minus 1. Another thing is y equals x. This is proportional. Okay, k is really 1 here. It's not like there's no k, so that's kind of like a tricky one that sometimes students get confused with. And the last thing for it to be proportional is it needs to pass through the origin. Oops. Needs to pass through the origin. Okay. I'd like to go through the do you know how questions together today instead of having you do them on your own. Okay, so Martin and Isabel go bowling. Each game costs $10, and they split that cost. Martin has his own bowling shoes, but Isabel pays $3 to rent shoes. So there's a lot of important information in here. Each game costs $10. That's important. They split the cost. That's super important. So if they're splitting the cost, that means they're each paying $5 per game. And then Martin has his own bowling shoes, so he doesn't have to pay for that, but Isabel has to pay $3 to rent shoes. So complete the graphs below. So for Martin, he doesn't have to pay for shoes. So if he plays 0 games, it's going to be $0. If he plays 1 game, it's going to cost him $5. Because remember, it's $10 per game, but they're splitting the cost. 2 games will cost $10, 3 games will cost $15, and so on and so forth. Connect the dots, makes a straight line. It's proportional. This one, Isabel, she has to, when she plays 0 games, she's actually still spending money because she has to pay $3 to rent the shoes. So $3 is about right there. And then it's going to be $5 per game since they're splitting the cost. So something like that. This one is not proportional because it's not passing through the origin. Which graph shows a proportional relationship? We just went over that. Martin's, because it passes through the origin. Choose one point on the graph of the proportional relationship and explain what the point means. Let's pick this point. Let's pick 210. You can pick any point you want. Let's pick the point 210. It means that if he plays 2 games, it costs $10. What equation represents the proportional relationship? Well, since it's $5 per game, since they're splitting the cost, it's y equals 5x. All right, that's it. You're going to do the practice and problem solving first page. I'm also going to assign the IXL section to you. And that is it. Have a great day.